for the charged tape experiment in Physics 2. So the purpose of this lab is understanding how neutral matter can become charged and the properties of those charges, and we're also calculating the electric and gravitational forces on and between charged objects. Some of the most important fundamentals here are Coulomb's law, and that's essentially finding the electric force between two objects. And since both of the tapes were positively charged, the same thing happened to them, these are going to be the same. Brief view of the results: both tapes, when ripped off the surface, became positively charged in the sense that they lost electrons, as it states here, and this is the ratio of atoms to electrons. So this was a pretty positively charged object because it's this many atoms per one electron. And tape 1 underneath tape 2 in part 2 of this experiment exerted a repulsive electric force onto tape 2 at a distance of 0.019 meters, and this distance was on the y-axis. The tape 1 was moving upwards. So some background and experiment design. The system is tape 1 and tape 2, and the surroundings would be everything else. The initial conditions is tape 2 is at rest. It's suspended in the air because it's attached to two objects that are lifting it off of the surface. And tape 1 is at the surface, and it's going to start lifting up to exert that repulsive force. So before we did the experiment between the two pieces of tape, we just ripped off one piece of tape from the surface, which was another non-sticky piece of tape on my table. So that was the surface that all of these tapes are being ripped off of. So after it's ripped off of the surface, we wanted to see its properties by seeing if it was attracted to my hand, other neutral objects like a mug or a candle, and then finally we wanted to see how it reacted to another piece of ripped tape. And it was repelled by the other piece of ripped tape, and this indicated a positive charge for me because I knew that skin is negatively charged and that the tapes repelled one another, so it was likely that the tape lost electrons in the process of being ripped. So part 2 is sort of what's explained here, where these are the initial conditions, and then you're going to slowly lift that bottom tape, the tape 1, up on the y-axis until it starts exerting a repulsive force on tape 2, which is again suspended in the air. So some of the calculations I did was to find the electric force of the two pieces of tape. Like I said, we can use the same charge here because they were both positively charged, assuming that it's the same charge. And then we wanted to calculate the amount of electrons lost during the ripping process, and then the ratio of atoms to electrons after the rip. So I found the electric force by setting it equal to the force of gravity, since everything was at rest. And then I rearranged it so that I isolated Q to get this charge, and then I divided the charge by the charge per electron to get the number of electrons. And then to find the ratio, I just found the area of an atom and the area of the piece of tape that I just got with the length and width, and then divided the area of the tape over the area of an atom, and that's how I got this final answer here. I did a similar thing in my code under calculations, you can see here, and then here are my answers. And another thing that we did in the coding was we created a vector that represents the electrical force, which is orange. As you can see, it is repulsive. These are two positive charges, so that makes sense. And then the gravitational is always going to be attractive between two objects. So the code and experiment complemented each other pretty well. The electric force, of course, was positive, and the gravitational force was negative, so attractive and repulsive. And some differences, though, would be the code had the pieces of tape operate as spherical objects, whereas they are not spherical objects in reality. And when quickly ripped from the surface, of course, the tape is going to lose electrons, leading to this positive charge. And this is what made the tape attracted to negative components of other matters and repelled by other positive matters. And potential sources of error is the mass of the tape was calculated using a very general calibration that I kind of got by Googling the brand of tape that I used. And if electrons had a positive charge, then the tape would become more negative after it was ripped. It would likely still be attracted to the positive components of neutral objects, but it would likely not be attracted to skin since, again, it's negatively charged. The tapes would still repel each other since they would both be negatively charged. And it's important to handle the tape minimally because the tape will lose its positive charge the more it interacts with negative and neutral objects. And thank you.